Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. The class of today is recorded. This class will be about a new section, a very interesting section 7.3. This section depends on 7.2, and the next section 7.4 and 7.5 will depend on this section, mainly about this section 7.3. This section is about the double angle formulas and the half angle formulas. In fact, the half angle formulas, they are just, you can look at them as a special case from the double angle formula. They can be obtained from the double. So if you really understand the double angle formula, you can, of course, conclude the half angle. We will see that together. Again, we will practice at the end how to evaluate expressions that involve inverse trigonometric functions. This will take us back to section 6.5. So let me start asking you this. What do you think? Is it okay if you have sine 2x? Is it equals to 2 sine x like this? Can we take the 2 out? Okay, as a common factor. Okay, good. So what is sine 2x? We will see together that sine, the double of the angle, is the double of the product of sine x cosine x. Amazing, right? What do you think? Is sine 3x will be 3 sine x cosine x? No. The answer is no. We will see also why. Why is that? Okay, so let's start with what I just mentioned, sine 2x. What is sine 2x? How to show what is sine 2x? In fact, sine 2x, it is sine x plus x. Is that correct? 2x is plus x plus x. And we have from 7.1 the addition formula for what? So what would this will be? Sine the first, cosine the second, plus sine the second, cosine the first, which is 1 real plus 1 real. It is 2 sine x, cosine x. And we have now this formula, the double angle formula for sine. The double formula for cosine, it is cosine to x equals to cosine squared x minus sine squared x. And I think you know why. Yes. By the same idea. Okay, let me show you here. I mentioned here this for you, cosine to x, because I expect that sine to x is so easy. So here again, you will apply the addition formula for cosine. It will be cosine x minus sine x sine x. Cosine x is cosine squared minus sine squared. What do you mean, Muhammad? Oh, it's okay. Now, this is the formula. What is good about cosine the double? Maybe good. Some of you, they found it not good. That you can write it in terms of sine and in terms of cosine only. Here it is in terms of both, right? We have cosine and sine. But you can write it in terms of sine only and in terms of cosine only. So we have 3 formulas, in fact. They are equivalent. And they can obtain from each other easily. How? How to obtain this? Just write cosine squared as what? Cosine squared, it is 1 minus sine squared, and it will be 1 minus double of sine squared. Or if you want to write it in terms of cosine, what you will do? You will replace sine squared by what? By 1 minus cosine squared. Now it will be cosine squared minus 1 plus cosine squared, which will be 2 cosine squared x minus 1. So no need to memorize them. You will of course by default, but if you know this, you can obtain the other 2. Okay, for tangent, you can prove it by the same. How to show this? Tan x plus x. Just do the formula. Tan x plus x, you can find it easily. It will be tan x plus tan x over 1 minus tan x times tan x. So these are the main formulas, ya shabab. 3 formulas mainly that we have here. And they can be, if you forget them, what you can do? Obtain them from the addition from the addition formula. Easy. Let's apply them. Cosine x is negative 2 over 3, and x is in the second quadrant. Find cosine to x and sine to x. Notice here, Shabab, again, don't write cosine without mentioning cosine what? Sine what? You should specify what is the angle. Because look here, what is this? Cosine what? And what is this? The double x. Be careful. Okay, what to do to solve this? What you want? You want cosine to x and sine to x. Which one is easier to start with? What do you think? Which one is easier, sine to x or cosine to x to start with?
Cosine to x.
Why it is easier? You are right.
Because we have the formula cosine.
We have also the formula for sine.
We have cosine x.
Look to what he is saying. Yes. Since I have cosine x, I can find cosine to x. What I'll do, I will just use this formula. The second one, look here. I have cosine, so by default, I will have cosine. If you have sine x, you can have cosine to x also. So cosine to x is easier to be found from knowing one, sine x or cosine x. So now what you will do, you will just square this and evaluate. Now, how to find sine to x? You need to find sine to x. You can do it in two ways. Method number one.
Square root of 1 minus cosine squared.
Again.
Square root of 1 minus cosine squared.
Cosine squared what?
X.
No.
The value that we get now.
Cosine squared to x.
Yeah.
So one way to use this formula, cosine squared to x is 1 minus cosine squared to x, which is the Pythagorean formula, right? But in this case, you need to know in which quadrant, because this will what you will get. Sine to x will be positive or negative. Which one will you choose, positive or negative?
Positive.
How to know?
He said
No, he said x, but this is 2x. This is the double. Be careful. He said x in the second. 2x, what do you think? If x is in the second, it means that it is between pi over 2 and what? And pi, right? 2x will be where?
double.
Which means quadrant number 3 or quadrant number 4, right? But cosine to x is negative. Cosine to x is negative. So where we are? In the third. The third is winner. So what is this? Negative.
Do you mean cosine x, not cosine to x?
Cosine to x. Cosine to x is negative. One way is to use the Pythagorean identity for the angle to x, not for x. Because you have cosine to x, you can find sine to x.
Can we use just x and then use x?
Yes, it looks like you prefer this, Muhammad. You can. Why? But you need to find what?
2x after
Sine to x. What is sine to x, Muhammad?
before
2 sine x cosine. You don't have sine x. You need to find sine x.
yeah, so
And to find sine x, you need to do the same. Either to use the Pythagorean formula for x or to use a triangle. I think you mentioned before, maybe one of you mentioned that we can use a triangle. It is one way. You have so many ways, Shabab. You can use also x, y, and r. The idea is they are equivalent. We need to find sine x. Sine x can be found from the Pythagorean formulas easily like this. Why you choose the positive sign, not the negative?
because
Where is x? X in the second quadrant. So sine is positive in the second. And that's it. Whether you use, of course, now sine to x will be so easy now. Sine to x will be just the product. The answer, this answer will be the same, whether you use the method that I mentioned before or this one. Okay. So this is why I say, Shabab, this section is interesting because it is like the top of the sections in chapter 5, 6, and 7. It combines all of them. You can use many ideas and tricks in this section. Now write cosine 3x. This is what I have asked you about it in the beginning. What do you think is cosine? We know that what is cosine to x. What is cosine to x? Cosine squared x minus sine squared x, correct?
Yeah.
What do you think? What will be cosine 3x? Is it going to be cosine to the power 3x minus sine? Because some of you, they prefer to make them similar to each other like this. This is not true. What do you think?
We convert it to the cosine sum formula.
How? Yes.
It would be cosine 2x plus x.
You mean the addition formula?
Yeah.
Yes. This is how to be solved. Yes, Muhammad.
Yeah, I believe you can use the same idea. Cosine x plus.
This is exactly what he said.
Oh, yeah, so
This is exactly what he said. I thought that you have another idea. It's okay. So you know now what is the tool. The tool is to write it as cosine x plus 2x. And let's see. Cosine 3x, it is cosine x 2x plus x. What you will do next? You will apply the addition formula for cosine. Which one you prefer to use? Because we have 3 for cosine, you know? We have 3 of them, cosine squared minus sine squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1. What do you think?
can we do
Cosine the first and the cosine the second, I think. The more familiar.
The best one to, he used the original one. You can use, by the way, the, oh, okay, sorry about that. Sorry. This is the addition formula for cosine.
Yes.
Sorry, I confused you. Yes. What I was thinking about is about this. I'm asking about this one.
Yes.
Which one we will use for this?
one step?
Okay.
Not for the addition. For the addition formula, we have only one formula.
Yeah.
What is it? Cosine the first, cosine the second, minus sine the first, cosine the sine the second. Next. Now for sine to x, it is so easy. We know what is sine to x. One formula. It is 2 sine x, cosine x. For cosine to x, what do you think now? My question is here. Which one is the best to be used? Because we have 3. Look at them. Cosine sine to x is this one. Done. Now which one? 1 or 2 or 3? What do you think? Of course, it is correct to use any one of them. It is not wrong if you use any one, but it is better to use a specific one.
I think so.
Abdullah,
3,
the third one. Why?
because we don't have sign.
The third one is the best. Why? No.
Because it will be, so we have one variable before the minus sign.
Abdul Aziz, Abdullah. Abdul Aziz.
The other one, the sine 2x, it will be sine squared, right?
Because we don't know.
We want it at the end to be in terms of cosine. So we will use the one that contain only what? This is why it is better. What, whether if you use the first one or the second one, you have to write them at the end in terms of what? Of cosine. So when you can write it in terms of cosine, do not delay that. Okay. So now we are done with this part. This part, now what we will do, algebra, just we will multiply now, distribute cosine x here, distribute here, it will be sine squared, right? Next, are we, do we have it now in terms of sine, in terms of cosine only? What we still have? Oh, this bad angle here, this bad function here. How to get rid of it? Write it as 1 minus cosine squared x by the Pythagorean formula. Now, it is just about what? Expanding. Simplify. Combine like terms. What do we have? So this is cosine 3x. Don't memorize it. No need. This is cosine 3x. It is 4 cosine to the power 3x minus 3 cosine x. Look, we converted the angle from 3x to what? To x only. What do you think? Is it possible to have question like this in the exam? This is just 1 year ago. If cosine 3x is a cosine to the power 3x plus b cosine, then what is a times b? What is a? What is b? From here. A is what? 4. B is what? Negative 3. And what will be the product of them? Negative 2. Okay.
So just about memorizing the formula.
No.
If you can, why not? It is multiple choice, but why you should memorize? Is it about memorizing? I told you, mathematics, it is not about memorizing. It is about skills. You can show it. These are the skills that you need to learn how to deal with them. Of course, you can think now when you practice, think about the same for sine 3x. You can also show it. You can also do this cosine 3x in terms of sine. They may give you this question, but in terms of sine, not in terms of cosine x. Okay. So you need to know the method, the way that you need to obtain it, not to memorize it. We are talking about sine 3x. Here it is. Now, how to prove that this over this equals to 4 cosine x minus sine x? Now, are you going to memorize this? No, because they might give you this question next exam, and they will write it as A, and this is as B, and find A times B. What you need to do is to use your tools. What are the tools that we have here? What do you think? You will start with the right or the left? It is not easy to convert from the angle to the third of the angle, 3 of the angle, the treble of the angle. So we will start with the left-hand side. Sine 3x, we don't have a formula. Do we have a formula for sine 3x? We don't. For 2x, we have. So for sine 3x, we will write it as x plus 2x. Then we will use the addition formula for sine. Then, what we will do next?
Now we have sine 2x and cosine 2x.
Separate. We can separate, right? But we can separate. I prefer that we can cancel here, right?
Yeah.
We will have cosine 2x over cosine x. I don't know if he did that or not, but I found it helpful, right? Just I will cancel this with this and this with this. When I first I will separate, then I will cancel. Then I will apply what? The formula. Now, which one we will use? Again, for this one, it is easy. This is why you will like, and you for sure you like sine 2x more than cosine 2x. Now, cosine 2x, which one is better? Not correct. All of them are correct.
Second one.
I don't agree with you. One, let's say this is 1, this is 2, this is 3. Which one? Why? Look at your target. What is your target? The right-hand side. It will be all in terms of what? Of cosine. So it is better to use the third one. Let's see what he did. Oh, he didn't distribute. He will distribute in the next step. It's okay. Now, what we will do, we will distribute or separate the fractions. Then we can cancel now. Oh, it is better. I know why he delayed that to this time. Now we have double cancellation here. So we will have now 2 cosine squared x minus 1 over cosine x plus 2 cosine x. It looks like we are far away. Keep your eyes on your target. Yes.
Why don't we just take sine and cosine as a common factor?
Yeah, sine what?
Sine and cosine.
As a common factor? How to do that? Here you mean in this step or in the above one, in this one? How?
No, the step that you wrote.
No, this is good. Let me mention this mistake. It's okay. What do you think here? What you can do? Take what as a common factor?
Sine x and cosine.
Sine x and cosine x, the product of them as a common factor, right?
Yeah.
Open brackets. Do you have here sine x and cosine x here? Is it a common factor, sine x, cosine x? Do we have here sine x, cosine x? Do we have here? I'm afraid, ya shabab, that you're still thinking about these issues, and you are like this when you have sine x and you think about sine like a product, sine x, right? This is a function. This is f of x. Okay, it is not a product. Okay, now 2 cosine squared x minus 1 over cosine plus 2 cosine x. What we can do next?
Make it as one fraction.
No, distribute. We will separate the fraction here. What it will be? It will be 2 cosine squared over cosine, which is 2 cosine minus 1 over cosine plus 2. What is the 1 minus cosine? Secant, negative secant. And 2 plus 2, it is 4 cosine x minus secant x, which is what? which is the right hand side, which is exactly, now we started with the left hand side, we have at the end the right hand side. Okay. Regarding this mistake, that when you take a common factor here, okay, like here, you can take, I'm afraid that, what is your name? Hassan. Can we take X here as a common factor? So it is like this, yeah, be careful about this. It is not a product, it is not a multiplication. This reminds me about a joke, a mathematical joke. Let me mention it here for you. Let me remember it, that if sine x, find the value of this function or solve it, right? So this, let's call it k, because I don't want to look at it. Now, one student, he simplified this to be what? N with N will be cancelled, and you have 6, so this is 6. Funny, right? So be careful. Sine x is not a product. We don't have a product of between letters here. Sine x is one word. Sine is just like f, so it is the function. So be careful about such mistake. Okay, now the first part of this section is done. The second part is about formulas that can called formulas for lowering powers. Now, we had in the previous formulas how to convert the angle from the double to the angle, right? When you have the double of the angle, you can write it in terms of the angle. Now, if you have it in the term of the angle, you can convert it to the double, but you will reduce the power. Look, when you have, we know, or we all know that sine x squared, it is 1 minus cosine squared x, right? But here, this is the Pythagorean identity, and we have the same angle here, the same angle here. No problem, right? Now, there is another formula, and this is, of course, will be used heavily in math 102 when you integrate. So sine 2x, you can also write it as 1 minus cosine the double of the angle. How? So this is another formula for cosine, for sine squared x. Again, you will use this, ya shabab. You will see, inshallah, in math 102 that sine 2x, the integral of sine x dx is negative cosine x plus a constant. But the integral of sine squared x is not direct. You cannot find it directly. And to find this integral, there is no way. The only way that you can use to find this, to write it as 1 minus cosine 2x over 2. Okay, so this is where we need this formula, mainly we need it there. And of course, there are many situations that you need to convert the angle, especially when you want to reduce. It is mainly about reducing the power. What is the power here? It is sine to the power 2, but here it is cosine to the power what? So we lowered the power. Similarly, cosine squared, it is 1 plus. And it is easy also to make a connection between this. This is the same, but here it is minus, here it is what? Plus. Now the question is, I don't want to memorize this without understanding from where it is coming. What do you think from where it comes? In fact, it comes from this. What is cosine? Do we have the proof here? Yes, I do. What is cosine 2x? You know this formula, right? This is the double angle formula for cosine. Yeah. Now solve it for sine squared. Solve it for sine squared. Add 1, subtract 1 from both sides, divide by -2. You will get this. Similarly, you know that cosine 2x is 2 cosine squared minus cosine squared x minus 1. Solve it for cosine squared. Add 1 for both sides, divide by 2. No need to memorize it, right? You can obtain it from the double. This is why I told you, just focus on the double angle formulas. For yes, please.
ليش الساين ما نقدر نوجدها بمعامل دلالة
You can, why not? You can, why you cannot? It is cosine to x. What do you want?
الساين نقدر نوجدها بدلالة الكوساين.
This is when you have sine to x. Sine 2x is 2 cosine x. If you want it in terms, you can do it. Why not? This will be plus or minus the square root of 1 minus sine squared x. You can by using the Pythagorean identity. Okay, but it is not easy. It is complicated. What is good about that formula for the double cosine that it is easier when you have it in terms, not more complicated, right? But you can, of course, you can always, wherever you have sine, you can write it in terms of cosine and vice versa. Now for tangent squared, what you can have, what is tan squared? It is sine squared over cosine squared. Just divide this expression by this expression. But this is not used heavily, by the way, because it is kind of not clearer than this one, but you can obtain it from just dividing sine squared by cosine squared. Let's apply them now. Express sine squared x, cosine squared is x in terms of a first power of cosine. The same question that Abdullah asked about. How to solve this?
Isn't that like the difference between two squares?
Difference?
1 minus cosine 2x over 2
So you will write cosine or sine in terms of what?
cosine.
But he wanted to be in terms of first power of cosine,
Yeah,
which
but-
means cosine to the power 1. It doesn't matter what is the angle. Just we need the power of cosine to be 1,
Yeah,
not
1 minus cosine 2x over 2.
again. What is the formula that you will use?
1 minus
Cosine squared or sine? He wanted in terms of cosine. So what we will do?
Everything to cosine.
We will convert
Everything to cosine.
everything to cosine.
Yeah.
How?
Sine to power.
half angle formula.
Slide before this, we took that sine.
One way,
2.
yes, one way is to use this formula, right?
This one.
Do we have them here? Here they are.
Yeah, those.
Yeah.
So we will use just sine squared. We will write it as 1 minus cosine over 2x, and this is like that.
Isn't it like difference between two squares?
Yes. This is what you meant. So what this will be? 1 minus cosine squared
Uh-oh.
2x over 4. This is another problem now.
Yeah.
It is not in the first power, right? It is in the second power.
Exactly.
In fact, what is good that we don't have sine squared anymore. But what is not good that we still have the power 2, and unfortunately we have the double of the angle, not angle.
Can we use again?
Why not? Why not? Apply it again. وإن عدتم عدنا. Now here, be careful. Now this is cosine what? Remember the formula, Shabab. Don't memorize the formulas just for x, please. We write them here. We should choose one letter to write it with. At the end, we should write it with x, with y, with whatever. But of course, think about x here like what? Theta. This will be what? 2 theta, right? Whatever the letter they choose. Of course, if we have here x, we have here 2x. This is the point. To understand it, say this. Sine squared an angle equals to 1 minus cosine the double of the angle over 2. So now, if the angle here, if this angle is theta, what will be this?
Theta over 2.
Theta over 2. If this is here, if this is here 2 theta, this will be here what? 4 theta, and so on. So think about it, just you will double here. So now here we have what? 2x. So it will be 1 plus cosine, the double of 2x, which is 4x over 2. Now we are done. Do we have it in terms of a first power of cosine? Yes. What is remaining is just a matter of what? Simplifying. Kind of algebra, just you will multiply 4 to distribute, simplify, combine like terms. That's it in the most simpler form. Is there another way? I see that some of you, they don't like this way. It is a little bit long, right? Now you have to deal with these tricks. Don't worry. You will be professional at them, inshallah. There is another way. It is not mentioned in your book, but I like it indeed. Yes.
Change convert sine squared to 1 minus cosine squared.
Then you are using the Pythagorean identity. It might be good. I didn't try it. Try. I have another idea, Shabab. When you see sine x, cosine x, is this remind you about something?
Sine squared without the 2 divided by 2.
Sine 2x over 2.
we know that sine x to x, the product of them is equals to what? When you double them, this is sine what? 2x, right? So sine x cosine x, if you divide both sides by 2, what you will get? Sine x cosine x is just what? It is, this one is the half of sine 2x. Is that right? So now when you square both sides, this will be squared, this will be squared, this will be 1 over 4, this will be sine squared. Let me show you here. I did add it. Here it is. Sine squared x cosine squared x. It is just sine x cosine x all. And sine x cosine x is the half of the double of the angle. Then squared. Now for this formula, which one you will use now? This one. But be careful. Here it is x. Here it is 2x. So when you have here 2x, it will be there what? 4x. And the same answer. But of course, in a short way. We didn't need here to apply it twice. The third part of this section is about the half angle formulas. And again, don't worry. You don't need to memorize them alone. You can obtain them from the double angle formula or from the lowering. We can call these, what we call them, lowering power formula. Formulas for lowering powers. So let's call them lowering powers formulas. We can obtain them from there. How? Do you remember what we have? Sine squared x equals to what? 1 minus cosine 2x, right? This is the lowering power formula. Now, if you have here x, it is here 2x. If you have here instead of 2x, if you have here u, here it will be what? U over 2. Take the square root of both sides. Take the square root of both sides. What you will get? Sine u over 2 will be positive or negative. The square root of 1 minus cosine u over 2, which is this formula.
There's a lot of formulas in this chapter.
Yes. In fact, they are all about the double angle. Just we are obtaining them from there. It is just a kind of manipulating with them. Now, similarly, cosine to x, cosine u over 2 is positive or negative the square root. What I want you to focus on more on this part is this one. We didn't give tan more attention at the beginning, right? Now it is time to give it the attention because it is now this identity is very effective in simplifying formulas. Tangent of the double of the half of the angle, which also can be written as shabab. It can be written also like tan x equals to 1 minus cosine 2x. Because it is just about any angle, any half angle formula can be written in terms of double angle formula. The same. Just it is about what you have here, you should have here the double. What you have here, you have the half of it. What you have here the double of it, and so on. Okay, now, of course, this positive or negative here depends on what? The quadrant of what? Of u over 2 of the angle, of this angle. In which quadrant? The angle u over 2. Let me show you there is another formula for tan u over 2, by the way. You can obtain it just by dividing this by this. If you divide sine by cosine, you will get tangent. This is not difficult. Now, let me start with just how to prove these. Just replace x by u over 2 in the formulas of the lowering power that we have before. Now, for tangent, how to show that? You will divide sine by cosine, you will get this. Then how to go from here to here? How to have this? The idea is so easy. We will multiply here by what? By inside the root. We will multiply by the conjugate of the numerator or the denominator. It is up to you. If you multiply, let's see here. We will multiply by the conjugate of the denominator. You can also multiply by the conjugate of the numerator to have one of these because we have two formulas. Now, if you multiply by the conjugate of the denominator, you will get this. Then you will distribute the square root. You will have the absolute value. Now, of course, there is this is interesting that 1 minus cosine u is non-negative for all values of u. This is a very interesting fact, by the way. It is not difficult to, it can be shown easily. And of course, because cosine u, you know, cosine u is between -1 and 1, right? 1 minus, it will be always positive, non-negative, at least it could be 0. Now, also what is interesting that sine u and tan u over 2, they have the same sign. The same sign. And you can check that by assuming u, if you assumed u in the first quadrant, if you assume that u is in the first quadrant, u over 2 will be also in the first quadrant. So both will be the same sign. They have the same sign, by the way. If sine u is positive, what is wrong with my pen? Is it not writing? It is writing there, but not here in mine. It's okay. Now, let me again, let me repeat this. It's, of course, it is just about proving the formula. Okay. Now it is back. Okay, as I said, 1 minus cosine u is non-negative for all u because u cosine u between -1 and 1. Now, also sine u and tan u, they have always the same sign. If sine u is positive, tan u over 2 is positive, and so on. You can verify that. So because of that, we will just replace sine u, the absolute value of sine u, by positive or negative sine u. And here we'll have the positive. This one just remove, no need for the absolute value here, because it's always non-negative. Now here it will be positive or negative, and here you have positive or what? Or negative. And because of that, these two signs will cancel each other. And we have at the end tan u over 2 equals to this. Now, if you want to have another formula, do you remember the another formula? We have this formula. We showed this now. We showed this 1 minus cosine u over sine u. The another formula is sine u over 1 plus. How to obtain this? I told you, you can obtain it from here by multiplying by the conjugate of, but no need. The idea is just multiply here. Multiply this by 1 plus cosine over 1 plus cosine. You will get the another one. So if you just know one of them, you can obtain the another one. I mentioned it here. The another half angle formula for tangent can be derived from this by multiplying by 1 plus cosine u, dividing and multiplying. Now let me help you, because I see that some of you, they are wondering, how can we memorize all of these identities? For this one, I want you to memorize only this because it is easy. Why it is easy to be memorized? What is tan u? Sine u over cosine, right? What is tan u over 2? It is still the same, but add 1. Right? Easy. Now you make a connection. Now, if you need this, just multiply here by what? 1 minus cosine over 1 minus cosine. It will be 1 minus cosine over sine. Let me show you an exercise that where we need this. This is, of course, about finding the exact value. How to find the exact value of sine 22.5. It is 45 over, so it is the half of 45. Then we will apply what? The formula. This is the formula that we, what do you think? Are we going to say positive or negative? Why? Which one in the first column? Positive or negative about what? It is about what? About u or about u over 2? It is about this angle. Who is positive or negative? Sine. Who is positive or negative? Sine u over 2. So this is in fact positive because the angle 22.5 is in the first quadrant. And you know what is cosine 45. Simplify. This is what you will have at the end. This is exact value. Find tan u over 2 if sine u is 2 over 5 and u is in the second quadrant. Again, we mentioned this before. Tan u over 2 and sine u, they have always the same sign. So what do you think tan u over 2 will be? Positive or negative? Positive. Tan u over 2 is positive. But tan u is what? Negative, because we are in the second. Look at it. Now, how to solve this? You have sine. What is tan? We have two formulas for tan u. We have 1 minus cosine over sine, or sine u over 1 plus cosine u. I memorize this for me. I remember this easily. Now, we have sine, we need what? Cosine u. So what we will do? We will use the Pythagorean identity. Why we write it here minus, not plus? Second quadrant. And here it is. You can use triangle, you can use whatever you want. I prefer now in this chapter 7, use identity. It is better because you need them in most of the exercises. Now cosine is negative, and this is good. Check that this is for the second quadrant. Now you have sine, you have cosine. What do you think now? You have to be smart. Which one we will use, 1 or 2? Who can tell me? 1. Sam?
We will use the first one because I have a.
So we will try to make cosine where? In the numerator. He's right. Samuddin is right. Because if you didn't, you need to rationalize the denominator at the end. So this is why it is better to have more options. Now, if you please try to use the formula number 2, you will find that you need to rationalize. And there is, of course, like more minutes you will spend on that. Now, do we have time for this part, or we should delay this to the next class? So let me stop here. Let me check that we still, I think this is the last part. Yes, it is the last exercise. Let me do it quickly, please. Now, how to evaluate expressions if you have cosine inverse? I think you get the idea, guys. What we will write this as what? We need to write sine 2 cosine x as an algebraic expression of x. So what we will do? Sine 2 theta. What is theta? Cosine theta is cosine inverse x. Now, what is cosine theta? Cosine theta is x, right? Sine to x will be the double angle for sine. So it's 2 sine cosine. Cosine theta is x, and you can draw triangle. So this is x over 1. And you can find the adjacent. Now you have cosine, which is x. This is x, just x. And this is what? This the opposite over the adjacent. Here it is.
Simplify cosine and cosine inverse.
How?
It's equal to x.
Cosine theta is x. From here you have this.
Yeah, in 2 sine and theta, cosine theta. Instead of cosine theta, I put cosine.
Cosine theta is x. It is easily just Muhammad.
Yeah, it's x.
Sine theta, it is square root of 1 minus cosine square, which is yes. You can use the Pythagorean identity. No need to use triangle. Do you got the point of Muhammad?
Yes.
Okay. Now, look, ya shabab, how to make a connection between all what we have done today. So what we started with, the double angle formulas. Are you okay with these formulas?
Yes.
If you forget them, what you can do? Obtain them from the addition formula. Okay. Then you can use these to have the lower, lowering power formulas. Just solve this one for what? Look, from this identity, you have this. From this identity, you have this. Okay. Now, from this, you can have tan squared. Just divide this by this. And from these lowering formulas, you have the double angle formula. How to do that? Just replace x by what? U over 2 and take the square root. You will get this. So it is easy to make a connection between them. So I wrote the map for you to make a connection between them. And this is all for today. Inshallah, we will continue next class. Let me stop recording.